I had an idea to build an air water generation system, a system that'll capture the water out of the humidity in the air. And I want to do it with just stuff I had laying around in my house. This old AC unit that I don't use anymore, and this swamp cooler from a previous build. Oh, and by the way, I'm gonna make it all powered off of this battery and solar panels. So how much water can we actually produce? How does it work? Let's nerd out a little bit about the science and figure out if we can't build our own, because these things are really expensive. Let's see if we can figure this out together. I'm Ricky, and this is 2-Bit Vinci. Huge thanks to our friends over at EcoFlow for sending over this, the Delta 2 Max. This little battery is going to power everything that you see here off of solar power. We'll talk more about this amazing little thing in just a second, but let's start with some of the design considerations. First of all, this old portable air conditioner. Now, if you have a portable air conditioner, you need to check if it has one hose out or two. If it has one hose out, you probably shouldn't really use it. It doesn't really do very much. It's blowing air out of your house, which means you have a low pressure zone, and you're just gonna have air seeping right back in from all the little cracks and doorways and stuff. So these things aren't really all that good. That's why we stopped using it. But it does have everything that we need to make cold air. The fundamental principles are that we wanna make the air hit that dew point and condense out. We want the water to condense out of the air. And then over here, we have a swamp cooler that has all of these pleats that should capture that water and run around. Basically, we're running this in reverse. Normally, you put water underneath, it pumps the water over the fins and it evaporates out and blows cold air into your house. We wanna go the other way around and see if it'll work. Take in cold air, see if it can hit those pleats and collect down below. How well this is gonna perform, we shall see. But first up, let's deconstruct this, because as I mentioned, we have a fan down here. This fan right here blows air up and over these two heat exchangers. This is the hot side, that is the cold side. What we want to do is we want to make it so that this fan is just blowing over the hot side, and we need to take this off and figure out how hard this is going to be to take it off and have this one be blown from the fan over on the swamp cooler. But first, a little bit of deconstruction. All right, so the good news is we've got it out here now. Here's how this works. That fan I mentioned, this scroll style fan, is just blowing air up, but we're gonna reduct it so that way this fan is only blowing air over the hot coil. All right, so we've pulled the wire out to check the temperature of the cold side and kind of extra slack, and we've removed all of that. Now we're gonna put it back together because we don't have to get back into this. Next up, we need to build a bracket so we can separate this a little bit more so we have a lot of airflow, and then close off this side for the hot side. We got our piece of wood cut, and this is gonna block this off so that way this fan is only blowing in one direction. All right, we've got that all sealed up. Let's do a little pressure check and just make sure everything is still working. Here's our old head unit. I just have it sitting out here. Power is on. We'll put it on cooling, lower the temperature sufficiently. I'm just looking for any leakage. That looks pretty good. So now this fan, hot air only. We now have to deal with this side. I'm gonna turn it off because this isn't getting any cooling, so this is gonna get cold and kind of saturated. So I'll turn it off. And now that this is all working, maybe I'll tape this down. What do you think? That's the control system right here. Now we'll put these legs on this side to hold the swamp cooler up. Nothing too fancy. All right, here we go. Level, iPhone level, altitudestore.com. I want a store, Juan. When are you gonna build me a store? Okay. Now we have some trapezoids to cut out. We're gonna use this foam board to make the shroud for our system. All right, so on the other side we have the foam board, but on this, for a window, we've got some plexiglass so we can look in and see how much water is being captured. And we'll put a foam on the outside, we're not looking in. But while the guys cut that out, let's take a minute and talk about the battery. By the way, there are some amazing Amazon Prime Day deals going on right now with EcoFlow's entire lineup. So we'll keep the links up to date in the description, but definitely check it out for some of the best deals on EcoFlow's entire lineup of amazing batteries. Links in the description. All right, we're almost done. We're just wrapping this up, and then we're gonna be able to do a little pressure test to make sure all the air doesn't seep from anywhere, but right through the heat exchanger, the radiator. All right, so if you look over here, we're pretty much done. We got the plexiglass up. All the air forced through here, goes in, hits that mesh, and the idea is that the air in here would be below the dew point, in theory, and will condense out. Now, how are we gonna power this whole thing? Part of what made me really excited about this project is that you could run one of these from anywhere. If you have 4 solar panels, which we do, and we've run wires down, we're gonna plug this into the back of the EcoFlow. The EcoFlow has 2 inputs for solar, for a total of 1,000 watts. Let's plug that in now. This is important because otherwise you only can run it for a couple of hours and then that's not very interesting. But with this, you could run it every day. And how much? Let's find out. I'm curious myself. All right, we've got the solar plugged in. Ports are back here. Speaking of, why don't we just show off some of the ports in the back? All right, we have 6 AC ports. You can turn the AC on and off. Down here you have your 12-volt stuff, cigarette lighter, and all of that. Solar inputs, and this is how you would charge it from the wall. So normally if you were to do like a camping trip, not have solar, charge it here, pull it off, and you're on your way. While we're back here, we're gonna plug in the AC and our fan, and we'll go through one by one and see how much power they're using. That's the AC. Here's the fan. All right, I just heard that click as well. All right, that's all we gotta do back here. Let's flip this back around so we can see the front screen. So we're at 93%, and right now our input is 734 watts. Now this is 4:30 in the afternoon. The sun is already way over in the sky. We did some testing earlier on. We were getting the full 1,000 watts out of this earlier, but we're not gonna get that. This is gonna start dwindling, but we are producing solar. There it is right there. Now, should we fire this thing up? Yeah? Let's do this? All right. We'll start with the AC. We have our beautiful control panel. Turn that on. Set the temperature really low. Okay, and we're on cool mode. That is the fan running. And the compressor's already on too. So currently it's pulling 1,200 watts. Let's give that a second. Normally they'll kind of level out a bit. This is probably a good point to talk about the capacity and what this battery can do. This is pretty amazing. I could actually power 2 air conditioners off of one of these. The maximum output is 2,400 watts, which is pretty amazing. More than 2 of those. In terms of storage capacity, this is 2 kilowatt hours. So right now running this, I could run it without solar for about 2 hours. But with solar coming in, I'm actually only using about 300 watts in total. And I think that power will settle around 1,000. Because remember now, this fan used to blow over both, but we've taped this off. So this is just blowing the hot air. This is actually producing ice because of how cold this is getting. So we need to turn this fan on to keep the air going over that coil too. There we go. So this is high speed. Why don't we set it to, ooh, that is freezing. So we have 2 components. You can already see the water is dripping down from that really cold coil. First of all, this system now is way more efficient because we have this fan moving all that hot air on that side, meaning that there's more heat being exchanged. And on this side, we have a whole second fan. So we've doubled, in essence, the amount of air flowing through it. You can already kind of see the water. The main water collection is going to be the radiator up here. And the reason is it's just freezing cold. So this is our primary water we're going to be collecting, but we're going to also be getting some dew on these grills, these vents, and we'll take a look at that. So with both of those on, we're pulling 1,400. We still have 1,000 watts more we can pull from this thing. That's pretty amazing. And we have the solar coming in. So tomorrow what I want to do, when we get full daylight, we'll charge this up and then we'll see how long we can run all of this with the solar coming into it. All right, moment of truth. I'm not gonna lie, we didn't really plan how to get water out of this very well, but here we go. This is 4 hours. Okay, there's 2 liters. We still have a little bit more. So almost 4 liters in 4 hours, all off of this and solar. We were not even using our own energy. By the way, there's a smartphone app. Open it up. And setup was incredibly easy because we already have other EcoFlow products. It just told me, hey, new product detected. I hit OK, and it added it right away. It was really cool. So here it is right here. And as you can see here, we're producing almost 900 from solar. It's 10:30 in the morning. That will be 1,000 fully maxed out, probably around noon. And we're using 1.49, about 1.5 kilowatts. Now, without the solar input, this would run for about an hour and 20 minutes, right? But with that solar input, we can run this pretty much for about 4 hours and collect that much water. Pretty amazing. Also, it's staying pretty cool, definitely quieter than the compressor and everything else. And it's just been bulletproof. It turns right on and it's powering all of that without any issue. And what's really cool in the app as well, I can turn on my AC or turn it off, for example, right from the app. My 12-volt DC and the USB ports up front, these little buttons here, you can trigger them all in the application. So let's really quickly talk about what we've accomplished here. The weather right now in San Diego is 71 degrees, an amazing temperature for this time in the summertime. And the relative humidity is 69%. What that means is 69% of the water that the air could hold is actually in the air. Now the dew point is 60 degrees. That means that if we can get the temperature below 60 degrees, there will be more than 100% humidity, which means the water cannot stay in the air any longer and it'll condense out. And that's what we've accomplished with this heat pump, because this side is colder than 60 degrees. As you can tell, here, all this water trickling down. Look at all that. So that's kind of the science behind this. And I have all kinds of ideas for new ways to optimize it. So first of all, this whole swamp cooler thing we put up because we were thinking, well, if the air in there is really cold, we might be able to capture more water out of it before it exits the system. But from what I'm seeing, there is some moisture in these channels, but it's not a whole lot. So what I would do in the future maybe is redesign this and make the air blow this way over the cold coils, make the cold coils and the hot coils kind of like that, and have that cold air go through the hot coils to better cool off the hot side and have better efficiency. And then collect all the water and maybe add some desiccants or other things to really absorb that water. But this might be an ongoing series where we try to maximize this and try to make more water with less energy and see how much we can learn. But that is a really awesome little one-day project, and I'm blown away by the results. I can't believe we're producing water out of the air. But that's not how you're going to use this. You're going to use it as a portable power station. Now, you can probably imagine we love EcoFlow. We have the Delta 2, which is a smaller one. This is 1 kilowatt hour and 1,200 watts output. The big brother, the Delta Max, has 2 kilowatt hours and 2,400 watts of output. And then we also have Delta Pros in the office. Those are 3.5 kilowatt hours, and they can take in 1,500 watts of solar input. That means that with 2 more panels, we could have powered this thing all day, producing water from the sun, which is absolutely amazing. But these are kind of the lineup, and there's quite a few options. These both can take in an extra battery. So if you wanted to add on capacity, you can just add them on later down the road. And there's kind of a product for every use case. They have a really wide variety of products, including generators. So in the event of cloudy days and long power outages, you can still produce electricity from gasoline or natural gas. And this one, the Delta 2, is ultra portable, but the Delta 2 Max, I think, is one I would have most of the time because it could just do so much, and it's still pretty portable. So, can you make a water from air generation system and power it with a Delta 2 Max? Absolutely, and pretty easily. If we had a smaller heat pump system with 1,000 watts of solar input, we could have ran it all day. But pretty impressive stuff. But odds are you're gonna use it for a couple of other things. Home backup power, perhaps. You could run a full refrigerator in your house for 14 hours with one of these things, or a TV for 15. I can power this laptop for like an entire weekend, pretty much. Plus, with lithium iron phosphate batteries, this will last well over 10 years and has some of the best recharging times in the business, whether it's on the wall or from solar. And with that app, you can manage it all, turn things on and off all remotely. So that's a quick look at the Delta 2 Max and just how much we were able to do with it. So, by the way, don't forget to subscribe and join us because we think we could do even better and build a system even more optimized to collect more water in a future video. So don't miss that. And until then, you got to check out this video next.